Hello, in this video I shall explain about the significance of comparators with respect to the sorting, how they are important, and then we shall discuss an outline of the sorting network. So, in the previous video, we have discussed about the component of the sorting network. The main component of this is the main component is a comparator, where comparator is a device. It is basically an input and output device. It takes a binary input. It takes two set of values as the input, and it produces an output x prime and y prime. Now this now now it can be further divided into the increasing comparator and the decreasing comparator, where the value x and y, where if the value x and y are being given, then x prime will hold the value, then x prime will be having the uh, minimum value as the output, while y prime will be having the maximum value. Similarly, with respect to the decreasing comparator, x prime will be having the maximum value, while y prime will be having the minimum value. The, the symbol for the increasing comparator is circle plus, which is being written at here, while circle negative sign is the symbol for the decreasing comparator, which is being written at here. Now we have then discussed that now we have to discuss about the significance of the comparators. That what is the significance of the comparator? A sorting network. Now, what is a sorting network? A sorting network is basically uh, it basically comprises of a series of columns. For example, you can be able to observe from the below figure that it contains a number of the columns. So here it is the first column, in which you can be able to see that this is the first rectangle, second rectangle, then uh, then they would occur a third rectangle and fourth rectangle, and up to some uh, uh, n rectangle n. Suppose there is some capital N rectangle. Small n is the number of the elements, and capital N is the number of the elements into the whole column. So there are so these n so this is a basically comparator, and this comparator can be either the increasing comparator or the decreasing comparator with respect to the requirement. With respect to the requirement, so these comparators, so uh, the execution, so the operations are getting executed in this comparator simultaneously. So this particular comparator will work simultaneously. This particular comparator will work simultaneously with this particular comparator. So all of the n comparators, capital N comparators, are executing simultaneously into the column one, and the input values are being provided to these computers with the help of the input bytes. So this is the input bytes. The significance of the input bytes is that they are simply providing the values. uh, Although you can be able to say that there is no significance of the bytes into the sorting, into the sorting operation, because when a program used to execute, then it doesn't supply the values with the help of the bytes, but it used to give the values with the help of some variables. So here those variables are being simulated with the help of the bytes. Those are being simulated with the help of the bytes. That rather than denoting the values with the help of some variables or the arrays, they are being simply shown with the help of, in a simplistic manner, with the help of the bytes. Now these set of bytes are being given as an input to these comparators. So the first line is being given as an input towards this comparator. So the second line is being given. So the second two bytes are being given as input to the comparators, and so on. Now, whatever the output is being generated by this computers, either into the ascending order or into the descending order, are again being shown as the horizontal lines, which you can be able to say that again these are the bytes. That from these two bytes some input is being given, and these two bytes are giving the are holding the output, which are being given towards this interconnection network. Now, what is this interconnection network? It is basically the topology on which this algorithm is getting executed. Now again, as I discussed into the previous videos, that these that this interconnection network that this interconnection network can either be that this interconnection network can either be the mesh or the hypercube or the ring or the linear array, can be anything. So so whatever the output is there with respect to these comparators, it will be given as an input towards this interconnection network, and the interconnection network will take the appropriate action, and it means that the comparator will perform the operation with respect to these interconnection networks, and the values are being forwarded towards the next column. And now again, into this next column, there are capital N number of the comparators are there, which will take the values in which will take the values as an input from the previous comparators, or the interconnection network. Now these now whatever the values which are being fed to these comparators are being given towards the next layer of the interconnection network. Now, what are the significance of this interconnection network? We will discuss about this thing into the next set of videos. But let us understand a few outline of this particular sorting network. That this is a whole sorting network which comprises of the input parts. With the help of the input parts, the inputs are being given towards the comparators, and the whatever the output is there with respect to the increasing comparator or the decreasing comparator are being passed on towards the intermediate wires. Now now whatever the outputs are there, they are actually getting executed onto the interconnection network. So these comparators actually execute onto the interconnection networks, and whatever the generated output is there is being passed on towards the next layer or the next column of the comparator. Now now whatever the values there, it is being passed on towards the next layer of the interconnection network, and in this way this whole process will continue. And whatever the values is being given, it is being given as the input in the initially, is being passed on by the intermediate wires towards the next stage. Now here in this case, the intermediate wires are there which are being given to the next stage. Finally, when all of the columns are being exhausted, then the last column, then with respect to the last column, to there are multiple comparators, uh, there are multiple comparators, and with respect to the each comparator, there are two set of wires. There with respect to each comparators, there are two set of wires which are coming out of it, and it is holding the output values. Again again I want to emphasize that that the wires have no significance with respect to the program. That when the programs are being written, then the values are being passed on with the help of the arrays or the variables towards the program, and in the same way the values the output bytes are also assigning the values uh, um, into the variables or the arrays as the final output. Now now each of these columns, now what are the significance of these columns? That these columns, each of these columns have a number of the comparators which are either the increasing comparator or the decreasing comparator. So with respect to the increasing comparator, it used to perform the exchange operation if they are not if the input values are not into the ascending order, then it used to arrange them into the ascending order by the increasing comparator. But uh, but if but if it is already into the ascending order, then it makes no effect on that value. It will remain as it is. Similarly is the case with the help of the decreasing comparator. With respect to the decreasing comparator, if the input values are into the decreasing order, if the input values are already into the decreasing order, then then uh, then, then the output will remain unchanged. But if it is in ascending order, then the decreasing comparator will convert them into the descending order. So each of these columns of comparators perform some permutation, exchange the values, or don't exchange the values in accordance to the in accordance to the increasing or the decreasing computers, such that the final column, now the final columns generate the sorted output either into the ascending order or into the descending order. Now now it will look, now this is an outline of the sorting network. Now with respect to the binary sorting network that I will cover into the detail into the next set of videos, it is a detailed diagram. It is a detailed diagram. Now you can be able to observe that these are the wires that with respect to the 16 values which are to be sorted, these are the 16 values which are being given as an input, and these are the increasing and the decreasing comparators which are working simultaneously. Now one thing is to be noted that that it that that the number of the columns into the whole network are being termed as the depth, and as the as there are number and if a particular sorting network has a large um, has a large number of the columns or its depth value is high, then the speed of the network is also very is also proportional to its depth. So if the number of the columns are larger, or I can be able to say that the depth of the sorting network is large, then in the same way it is directly proportional to the speed of the network. Then the speed of the network will also increase, because multiple operations are getting executed simultaneously into each column, and in this way this whole process is getting continued. Now uh, now uh, now if we want to convert a sorting network into the a sorting network which is originally being designed for the parallel architecture. If we want to convert this into the sequential sorting algorithm, then we can convert it into the sequential sorting algorithm by implementing these comparators with the help of some functions, that this particular increasing comparator or the decreasing comparator will work, um, um, has to be simulated with the help of the sum function. So they have to be evaluated into the software with a compare and exchange operation. So we have to perform the compare and the exchange operation, and such that the x and the y value are being compared and they are being exchanged. Now now into the parallel architecture, all of these comparators into the first column are executed simultaneously. Similarly, into the second column, all of these comparators are getting executed simultaneously. Since if we are implementing this same algorithm into the sequential sorting, then all of these comparators will not execute simultaneously. So this so a single column is converted into the n capital N sequence of the uh, um, functions. That first this first the output with respect to this particular comparator will be executed, then the output with respect to this comparator will be executed, and so on. In this way, the each column will be executed sequentially, and hence if we will convert is bitonic, and hence if we will convert a sorting network which is acting simultaneously or acting parallelly onto the parallel architecture, onto the sequential uh, uh, onto the sequential uh, into the sequential methodology, the computation complexity will become high, will become greater than the um, sorting networks. So now we should discuss about a particular sorting network which is known as the bitonic sorting network. So here, next we will discuss about the bitonic sorting network into the next set of videos. Now the the computation complexity of this bitonic sorting network is theta of log square n, which is a significant improvement if we will consider about the sequential algorithms, because in the case of the merge sort and the heap sort, we know that they have the complexity as theta of log square n. So here in this case, we are able to observe that the computational complexity is in fact uh, is um, is in fact only logarithmic or the square of the logarithmic theta of log square n. But if we will implement the same algorithm by tonic sorting,